This video is showing the solutions for the 6G4Z3002 Linear Algebra and Programming Skills examination from 2015. You will be asked to answer 5 questions, and if you answer more, we will give you credit for the best 5 answers. So question number 1 is on linear algebra. One part A is concerned with matrices, and one part B is concerned with vectors. So for one part A, we're given 2 matrices. A is a 3 by 3 matrix and B is a 3 by 1 matrix. 1A1 asks you to determine A times B if possible. So to work out A times B, first of all we have to check the dimensions, check that we can perform the multiplication. And because the number of columns of A is equal to the number of rows of B, we can perform the multiplication. So to work out the element in row 1, column 1, we simply multiply row 1 by column 1. So that gives us 1 times 1 plus 3 times minus 1 plus minus 2 times 2. So we get 1, take away 3, take away 4, which gives minus 6. To work out the element in row 2, column 1, we multiply row 2 by column 1. So we get 1 plus 0 plus 2, which gives 3. And finally, to work out the element in row 3, column 1, we'll multiply row 3 by column 1. So we get 0, take away 4, minus 6. That gives minus 10. For 1A part 2, we have to find a cofactor of 3 in the matrix A. So that means we delete column 2 and we delete row 1. And that leaves us with a 2 by 2 matrix, 1, 1, 0, minus 3. We find the determinant of this matrix. And then, because this element is in row 1, column 2, 1 plus 2 is 3, so we multiply the determinant by minus 1. So that's going to give us minus 3 plus minus 0, so that's minus 3, and then we negate it, so that gives you 3. So the cofactor of 3 in matrix A is 3. The final part of one part A, we want to solve for x when AX is B. So here is our system of 3 equations in 3 unknowns written in matrix form. Now we could find the inverse of this matrix to find x, y and z and then pre-multiply both sides by A inverse. But I'm sure you'll see here it's much quicker to simply perform row reduction. Okay, because we've already got a leading 0 here in row 3. So we need to make this leading term here in row 2 0. So we want to get rid of this 1. So we can manipulate rows 1 and 2 to get this to 0. So we're going to say that row 2 goes to row 1 minus row 2. So row 2 goes to row 1 minus row 2. So you'd have 1 minus 1 is 0. 3 take away 0 is 3. Minus 2 take away 1 is minus 3. And 1 take away 1 gives you 2. So this is our new row 2. And then in row 3 we now need to get rid of this leading term, which is a 4. And we can manipulate rows 2 and 3 to get rid of the 4. And I'll leave you to show that the new row 3 is this. And once we have row 3 in this form, then we have 3z is minus 2. So we can just get z is minus 2/3. Once we know z, we can back substitute. So we can substitute for z to find y. In this case, we get y is 0. Once we know y and z, we can back substitute again into row 1. And we get x is minus 1/3. Moving on to question 1b, which is concerned with vectors. So 1b part 1, we want to determine the vector a minus 5 times b. So a is this 3-dimensional vector, b is this 3-dimensional vector. 5 times b, we just simply perform scalar multiplication, multiply each element by 5. And then we add and subtract corresponding elements in the vector. So to work out the elements in this position 1, we have minus 1 and then take away 5 times 2 is 10. So we have minus 1 minus 10. So this is the leading term here, is minus 11. And then to work out the second component of the vector, we have 0 take away 5, so that gives us minus 5. And to work out the third component of the vector, we have 4 minus 5 times minus 5 gives you plus 25. So 4 plus 25 will give us 29. For 1b part 2, we want to calculate a dotted with b. So here's the vector a, here's the vector b. To work out the dot product, we multiply corresponding elements and then add them together. So we have -1 times 2 gives you -2, plus 0 times 1 gives you 0, and plus 4 times -5 gives us -20. So we have -20 plus 0 plus -20, which gives the -22. So that's the dot product of A and B. Next, we want to find the length of the vector B. So here is the vector B in the form with I, j, and k. We want the modulus, or the norm of this vector. So this is called the Euclidean norm. So we simply square each component, add them together, and then take the square root of the resulting answer. So here you can see we're going to get the square root of 4 plus 1 plus 25, which gives us root 30. So the length of the vector B is root 30. And then finally, 1b part 4, we want to determine a unit vector perpendicular to A and B. So we need to find a perpendicular vector to A and B. So we take a cross product of A and B to find a perpendicular vector. So we write down the I, j, k are the unit vectors. And now here is the vector A, here is the vector B, and we simply find this 3 by 3 determinant, and we get a vector. So this vector is perpendicular to both A and B. Now to find a unit vector, we divide by the length of this vector, which you can see is root 26. Now you'll notice for this question there are two possible answers, because this vector is perpendicular to A and B, and obviously the negative of this vector is also perpendicular to A and B. So either of these vectors is perpendicular to A and B. And that concludes the solutions to question number 1.